Good morning, everyone. Thank you for joining today. Good morning once again. Thank you for joining today. Today we are going to uh, discuss about video foundation course, and I really appreciate every one of you taking your time to register for the session and for your interest in this session. I'm very confident this session will be extremely useful for both those who are new to CCTV as well as those who are already working on CCTV solution. And the course is designed not to be specific to one role. It is a general discussion. It's a general topic covering all aspects of CCTV, from the camera sensor all the way to the control room. We are covering up in 4 days. So the goal of this session is to give you a broad perspective of where CCTV originated from and where we are today. So it's like a crash course for someone who's new and also a revision for those who are already in this field. And the main purpose for developing this course is we are in this fast-paced environment where many of you are in directly involved in CCTV without much experience on what happened before you joined the CCTV, without much time to give or dedicate to learn the basics of CCTV. So for them, it will be many of the things will make sense, many of the words will make sense to you as we go about in today's training. So a little bit about myself, Samuel Kumar. I'm the technical training manager for Hanwa TechWin, Middle East and Africa, and my goal is to uh, exclusively for providing all activities related to trainings, events within the Hanwa TechWin profile in Middle East and Africa region. I work with customers, consultants, end users, and system integrators to train on our products, Hanwa TechWin products, and also certain design aspects for consultants. All right. This course is brought to you by Hanwa TechWin. We are a South Korean company based in Seoul. In short, one of the um largest companies in the CCTV market, eighth largest company in South Korea, and top five ranked in the CCTV business. Right? We are not just a single company; we are a conglomerate. We are a group of companies. Hanwha is a group name, and Hanwha TechWin is a subsidiary of Hanwha Group. Hanwha TechWin manufactures CCTV and access control, and the product name that we manufacture, we call it Wisenet. So Hanwha is the group name, Hanwha TechWin is the subsidiary, and the product name that we manufacture is Wisenet. We have presence in solar, we have presence in defense, we manufacture military equipments, we manufacture aerospace equipments, we are into solar panels, construction, petrochemicals, over more than 50 years in the industry, in the manufacturing business. In CCTV, over 30 years. All right. So let's dive into today's topic. And to summarize what we are going to learn today is basically anyone who's in the CCTV uh, field will realize that there are plenty of brands in the market, right? You probably send out an inquiry and you might be approached by plenty of um, brands, which some of them are famous, some of them are not really known. So in this training, we have to get, you will get an idea on how to select the vendor. There are 300 vendors, but I'm not saying there's only one vendor solution for your project, but you need to shortlist a couple of vendors suitable for your project. See, the project can be a house, it can be a shop, it can be a mall, it can be city surveillance. So depending on the project, you have to evaluate what vendor will suit your requirement. Okay. Next, we will talk about the technical aspects. Um, what makes a camera? We all look at camera as one whole unit, which is true, but there are many things that go in developing the camera, right? Different components that make the camera. So we will touch on them because what you put inside, what components are inside, is what you get as an output. The good image quality or the good processing, everything depends on the components. So we will see where what are the important components, because that's where um, the variation occurs between different brands, and that's where the performance varies between different model numbers, right? So we will touch upon that. Then next we will see one of the most common features, WDR, and what is the meaning of WDR, and related, we will see a short demonstration as well, and we will take a break. And after that, we will talk about the other aspects of CCTV with related to lighting. As you know, CCTV is entirely dependent on image quality, and there are many components that affect the image quality. One of them is the light. So we will be looking at highlight compensation, low light technology, thermal cameras, and other things. All right. So that is for today. Then similarly, we have other topics you would have seen in the agenda document, day 2, day 3, day 4, and so on. So the PowerPoint will be emailed to you. If you have not received, you can just let me know. Can post the link for you to download it. All right. And if you have any questions, you have to post it in the Q&A or in the chat window for those who join by Teams. I will answer them immediately as we move along the topic. If some questions are out of topic, it will be answered after the end of the at the end of the session. Okay. Then this is a certified training. We will give you more information about it before our first break. So there may be one or few more people joining in another 5 to 10 minutes. For the benefit of everyone, before our first break or just after the first break, I will be explaining about the certification and how it looks and what are the criteria for the certification and so on. All right. Okay. So I have disabled my video on purpose because to help with the bandwidth. So you have seen me. This is me, Samuel. Uh, yeah, you can always add me on LinkedIn, and we can be in touch if you have any further questions. All right. Okay. Now, global ranking. Uh, this particular slide is to give you an idea of how different companies are ranked. And this is one of the criteria for you to check what kind of a company you're dealing with. Now, in order to better understand this, I give this example. Let's say you are going to meet with a very high-end customer. Let's say you are going to meet with an airport customer and you talk about your company. When you talk about your company, you will not be saying that I started the company yesterday and I have all so and so. It cannot, it it is not possible. You cannot work with such customers if your company does not have the experience or company does not have the backing or the financial capability to handle the project, right? So you talk about different references that you have completed. You talk about the different, if you have different divisions, you talk about it. You talk about your history, where you started from. You talk about your assets and so on. Same way, depending on the project, you need to understand what kind of a vendor you're working with and what is their global presence. There are other reasons for this global presence. We will see in the coming slide the word global, how important that is, because there are many brands which are selling only for specific country, right? And which is okay, but in case if you are working on a if in case you're working on a project that requires, um, features that are used, in terms of, let's say, latest technologies and so on, you will have to work with a company which is globally oriented. Let's say if you're working with a company which is local, there is a chance that the technologies that are already released in other countries have not yet been applied to that particular local company. And also there are other global standards, certifications that a product carry for safety and secure, for safety purposes, for the other quality purposes, certification. So they may not have that. So anyhow, we'll go forward and start. Okay, the first thing is global ranking. Now, in this ranking, what I've taken is a Fortune 500 ranking. This ranking list you can take from anywhere, anywhere. For example, if you go to, so anybody can get access to this list. It's called Fortune 500 list. What is Fortune 500 list? All the companies in the world put together, the top 500 companies. All right. Why did I mention about Fortune 500? What is the point in mentioning a Fortune 500 company? All right. So there are many companies in every country, right? Now imagine all the companies in the world put together, your country, your continent, all the continents, Asia, America, Russia, North America, South America, all put together. The top 500 companies get listed under this ranking system called Fortune 500 list. Okay. Now, if you're working with a company that is already listed in that ranking list, that tells you many things about how the company has achieved or strived to reach that level, how much of a global presence they have. It's like a single statement which explains about that particular company, right? So that's something that you can look at. Other than that, what you're looking at is the Fortune 500 ranking that was taken a year back. We are ranked around in the middle. There are other companies which you already know, like Honeywell, Canon, Schneider Electric, Panasonic. They're all listed in the Fortune 500 ranking. If they are not listed, it's still okay. You should be looking at, let's say, maybe you can expand the list to, let's say, Fortune 500 um, or within your continent, you can check who's the top 500 companies and so on. So it is still okay because there are certain companies which are not listed. Um, for example, uh, like Pelco, they may not be listed, but it is okay. However, if your company is listed as a Fortune 500, that gives you a single statement. All right, this company has worked, has strived, has all the necessary requirements to um, to be in the top 500 and to be present globally. All right. Certain privately owned companies will not be listed. So you will not find if a company is owned by one vendor, it will not be listed. One owner, it will not be listed. Or if it is owned by the government, it will not be listed. It should be a publicly traded company. All right. Next. So first thing that we checked is whether it is a global company, Fortune 500 ranking. Second thing is the word global. If you work on a product, for example, Let's say you take a camera from a vendor A. Let's say the vendor A has offices all over the world. It could be USA, it could be Canada, it could be Europe, it could be Asia, it could be Australia, it could be Middle East. Now, what contribution that each of these offices do is they make sure that particular product is suitable for that environment. The product is suitable for that country regulation. So you have ground level feedback sent to the vendor head office. The head office can be in Korea, it can be in US, whatever. So wherever the local offices are present, people there, the person there will send feedback and say, this camera needs to be tested for 60-degree operating temperature. Or a person in the US or Canada might say, I need my camera to operate at minus 30 or 40-degree temperature. So overall, what you get is a product which is globally tested. Overall, you get a product that has been tested for different environments, different conditions, different quality requirements, and make sure your product is well matured. Right? There is no factor maybe that can cause certain uh, you can say failure. So I have heard of a company where it's a very popular company, but right now they are not active. Uh, in It was a US company, they're quite famous there, but when they had supplied cameras to the Middle East, some of the camera lenses were falling off because the glue which was used or certain you know whatever material they used to attach the lenses to the camera sensor, it was not tested for the UAE operating temperature or the Middle East operating temperature. Now, it might have worked probably in the North America, but it did not work in the Middle East region. All right, so this is a real case scenario. I have heard of a camera which stops working after when the temperature is at the peak, let's say 45 to 50 degree, which occurs during the noon time in Middle East. Some of the cameras are switching off. So these are certain new brands which are exploring different market. You need to make sure that they have a global presence. All right, they have products installed globally. All right. Next, R&D team. R&D team is um, every company. One of the key success factors is their R&D team, research and development. Okay. CCTV, the amount of developments that happen is much, it's just like any other technology, right? Um, 10 years back, we had IP cameras, but ever since we had IP cameras from analog to IP, today you have different new technologies like low light technology, you have multi-sensor technology, you have artificial intelligence, um, you have uh, you have certain analytics inside inbuilt in the camera, edge level customization. So there are many things that are being added onto the camera. And the reason for adding that is to make that product efficient to the current requirement. Now, if a particular company does not have an R&D team and it is being outsourced, let's say, let's say you're buying a camera from company A, okay? Let's say you're buying a camera from company A and you have installed the camera in a region, let's say United Arab Emirates. Now, there are certain regulations which is asking for, uh, let's say, they say I need specific frame rate, I need specific settings in the camera. Now, if your vendor does not have an R&D team, then the chances are that uh, they are outsourcing it. So that means they will simply say we cannot do it. They don't have the capability to do it. They have to outsource, and they may not do it because of all the countries in the world, only one city or one country requires this extra feature. It will not make sense to them, right? So that is one. Second thing is New technologies, when new technologies are being introduced in the market, the one of the example is H.265 to reduce the bandwidth. Today, artificial intelligence to improve the camera efficiency, to act like as if it's like a real human being. It can decide by itself. So, if you need all these new technologies to be implemented in the CCTV, you need somebody to basically test it out. You need somebody to implement all the technology in the CCTV camera, check whether it works with the VMS, check whether it is integrated to certain systems, check whether it is backward compatible, make sure it works fine with the recording. So all these things require an R&D team. All right. So if your vendor has an R&D team, they'll make sure whenever there's a new technology, you will I mean, you will not lag behind. For example, um, today you have artificial intelligence, all right? If if a vendor has their own R&D team, you can expect them to provide you that technology within a year's time because they are already working ahead to make sure those new technologies are integrated. However, if they don't have it and they depend on someone else, it can take 3 years to 4 years for them to implement. So these kind of things you will see as you work closely with the vendor, right? Next is manufacturing plant. Manufacturing plant allows flexibility. There are many projects um, which require customization. Maybe a certain country you have to remove certain components. Let's say Jordan, you cannot have cameras with built-in microphone, so you need to remove them. There are certain countries where you need certain level of a customized, you can say, settings in the camera or a custom shape for the camera because that's what works for that situation. Maybe a pinhole camera, or it could be let's say one of the recent projects that we did was for Expo. They needed a customization in the camera. So in order to provide certain customization and release a new product, uh, you need to have a manufacturing plant. Otherwise, again, it's not going to be possible. Okay. And R&D team and manufacturing plant, both of them go hand in hand. I can give you an example. Let's say tomorrow there is a new regulation, or tomorrow there is a new requirement for your country. In that case, you will require a CCTV which complies to the new regulation, right? Okay. Okay. Now you go and approach a vendor. The vendor says, "All right, this is a new regulation. We have never seen it before," and they will say, "All right, we will work on it." But there are two ways to work on it. One, if they have their own in-house team, they can prioritize it and start working on it to make sure no more business is lost or business continues. However, however, if a vendor is outsourcing the product or relabeling or OEM or using OEM, just putting their brand name, that means um, whoever is responsible for releasing that product, the product manager for that particular company, has to justify to the CEO of the company saying why this particular feature which will be releasing tomorrow, was not factored in when they first launched it, or or it will be considered. Okay, another reason is it will be considered as a variation. For example, um, all right. So let's say there is a new feature required, then uh, the product manager of the company will go to different suppliers and say, or sorry, the product manager will go to the supplier or the OEM supplier and say, see, I this particular feature needs to be added for this country to start selling, and that supplier will say, all right, this is my turn, and he's going to give a variation, and the variation will include R&D cost, testing cost, development cost, manufacturing change cost, and certification costs. So all that things will be included. Now that particular product manager will see the cost of this releasing new feature. He might just simply say, all right, let's forget about it. When we do a product revision after 2 years, then we will think. Till then, your feature will be put on hold. All right. This anyone who has been working in CCTV for at least 5 years will have an experience. You might have approached a vendor and they will tell you, all right, we will look at it in the next release of the product. All right. So that's why, that is one reason. That is a, I mean, the reason for that is most of the time they are doing an OEM. That means they need to get a new variation code. They need to or look for new suppliers. They need to shortlist the quotations from the OEM suppliers and so on. So it's kind of a long process. So that's why they delay your request. All right. Second thing, uh, the benefit of having your own manufacturing plant is um, when a particular vendor is designing their product, they will design it with a future-proof mindset. Okay, all these things you have to know because uh, this what helps you to actually shortlist a very good vendor for your project. There are many good vendors out there, so and there are also many vendors which can give you a very hard time. All right, so manufacturing plan. Let's say a particular vendor has their own manufacturing unit and they are not doing an OEM. Okay, think of it this way. Uh, let's say you are a system integrator. You are a system integrator. You are providing a design to a customer. You will provide a solution exactly as per the specification. If the customer comes back and tells you, I need an additional camera, or if he tells you, I need an additional feature, you will submit a variation, right? Same thing. If a particular vendor is doing an OEM concept, all right. Let's say a vendor is doing an OEM concept. First thing they will do is they will list out all the features that is required today. They will write down, let's say, 10 features. Then they will say, I need a camera with so and so resolution, so and so protection, so and so feature, so and so lens. That's it. All right. They will take quotes from different OEM suppliers. Done. Now, and then whoever is the best and lowest, they will go ahead and finalize and start a contract with them for 3 or 5 years. Done. Now, whatever feature you wrote in this month, December, if you go back after 6 months, those features are not relevant anymore. You need more features. You need something new. You need what you needed today is not very important after 6 months. So then what happens? There is a feature gap. So now, when after let's say 6 or 7 months, the product gets released, and now the region requires some additional features, some new features. Again, that particular vendor has to go back to the OEM supplier and request for a variation to add those features. So these are the kind of things that go in the background if a particular brand does not have their own manufacturing source. Okay. All right. So usually these are taken very lightly, but at first instance they may not make a very big difference. But as you work on projects where you need long-term support, long-term flexibility, you just have to make sure you are choosing the right product. Okay, all right. Training center. All right. Very short. We'll go through training center. If uh, nobody knows a product more than that particular vendor, right? There are many CCTV brands, but it's like this. Of course, every car you need to move the gear, you need to switch it on and drive using the steering wheel. But behind the dashboard, there are many functions which differs, many features which can differ, right? That changes from vendor to vendor. Same way with your mobile phones. The simple function is to make a phone call, but the feature set can change from vendor to vendor, right? Same way, a camera is supposed to look at video, that's okay, it can do it. But the way you can optimize the settings changes from vendor to vendor. The words can be similar, but the way you optimize it can change from vendor to vendor. So, in order to have the best of your investment, to make sure you get the best from the product, you have to get your engineers trained from that particular vendor. You buy from a vendor which has 10 features. If you're using only two features, that means you have invested in 80% of the extra features which you're not using, right? And they are all security related features. So you can basically make sure that whoever you're working with has a training center or has a training provision, a dedicated training provision to make sure your project is handed over smoothly, right? There has to be a knowledge transfer from the vendor to the system integrator or to the field technician. You need to have that in place, all right? Next is a local team. Um, for you would have seen, or many of system integrators, you would have seen in the specification document, it will be written the vendor should have a local presence, a local office, local team to do timely support. You have an emergency, you need a support. You have a certain issue, you need a support. You need to face regulators, you need to face some auditors for about the product. You need a local team. You need someone with a lot of knowledge on the product. You need a local team. So if that kind of project you're working with, you make sure you have a it has a local team. Then back to the training. If you're an end user listening to this, if you're a consultant, you can always specify in the specification document saying whoever is working on the project must be certified by the vendor to do design or to do configuration. There are two levels of training: design training, that means choosing the right product, and then configuration training to make sure as per the design it is configured on the site. So if you include that, you make sure you have people who are certified working on your projects. Okay. Next is experience. A vendor that you're working with should have at least 5 to 10 years of experience. If your project is a very critical project, you should have at least 10 years of experience. References. References are proof of a particular product which has worked in that particular environment and has passed through customs, it has passed through regulations, it has passed through authorities, it has been tested in the environment, and it's successfully running, right? So references is something that you have to look for if a particular project has a reference in that field. What if they don't have a reference? That means depending on the seriousness of the project or the application of the project, you can do a test. You can do a proof of concept test. You can run the camera for a week or a month and get an idea how it operates in daytime, nighttime, and then move on with that particular brand. Last is actually it should not be last. It's a cybersecurity. You should be working with a vendor which believes and applies cybersecurity, right? It should be in the core or the heart of the company that they take cybersecurity seriously, right? And there are many companies who talk about it, but they don't really apply it. Uh, so you should, one way is to check whether that company has had any major serious vulnerabilities in the past, right? So you can refer that. Okay. Vendor trainings like pre-sales trainings, post-sales trainings, configuration trainings, and so on. These are examples of vendor trainings. Offices which you can go to any company's website, you can see in there about us, about their office locations, contact us. You can find information like this, where they are located. I'm using our own as an example because I'm authorized to use our own company information. So I'm using it as a reference during all this training. Okay, so we have here, we have so these are main offices. You can find almost any reputed vendor will have 20 plus offices, 20 plus. Okay, okay, what is a warning sign? If you see a company which has USA, one Dubai, and one in, let's say, China or Vietnam or something, if they have only three offices, that means something is wrong. They might be shipping from here, they might be taking it to USA, and they might rebrand and say made in USA and things like this. So these are like warning signs which you can check and make sure. If you're buying for your house for two or three cameras, it's okay. But for large projects, for commercial projects, we need more support and other things. Just make sure you go through this vendor checklist. Okay, quality and reliability testing process. This is just a video to show you what are the different tests a particular vendor does. And you can ask for them, by the way. You can ask for the report. Drop test. You can, if during transportation, during when they throw the cardboards, when they transport, will the equipment be in the exact same position as it left the factory? Power test. What if you give the wrong power? The camera will fail or it will still withstand. Maybe is there any surge protection, right? That can happen. Just because you inserted a wrong power, the camera should not blow up and then you have to go and return the camera and have all this headache, delay the project. So these are certain things which they do. Next is alt test, halt test. What if the temperature increases? So what if the temperature continuously increases from morning till afternoon? There is a steep increase in the temperature, right? What happens? What is the breaking point? What caused the breaking? What caused the issue in the camera if the temperature keeps on increasing? So these kind of test, halt test, alt test. What if, we always think temperature increases, okay, camera can have issue. What if humidity and temperature occurs at the same time? What if, different factors that occurs at the same time? So this is called um, accelerated life test, and then the next one is Hall test. Multiple scenarios. What if different things go wrong in a camera? These are the different tests they do. Then, of course, waterproof test. Then handling test. How many times you keep operating the same thing. Then, of course, image quality test. Does it produce the actual color? Does the sensor produce clear distinction between different colors and so on? You can always request a vendor and say, I want to have a look at this testing lab. But yeah, it requires you to travel to that factory and check. So you can inquire about this depending on your project. References you can look for, specific vertical references, uh, hospitals, commercial centers, exhibition centers, because there are certain small factors which are slightly different. So you can have a look at a vendor whether they have references in that field. It can be in that country or it can be in other region. All right. Now comes the next part where we talk about the camera and what makes a camera. Okay. All right. So what makes a camera? If you look closely, there are many components that make the camera. The camera body. It can be plastic, it can be metal, it can be stainless steel, or it can be a special housing. Plastic body is used for indoor purpose because if you look at many of your if you look at your ceiling, you might see your lighting. There is no screws outside. They're all flush mounted, right? So, or probably if you have a CCTV camera on your ceiling, you can also check some of the cameras. They will not have any screws outside. But how are they mounted, right? Because they use plastic housing because it uses less weight, so it can be easily mounted with a clip. And even if it falls, it is not going to hurt anybody because it's a less weight equipment. And the painting on plastic is quite smooth. It blends with the ceiling, white color ceiling. So that's why plastic housing is generally used for indoor application. What about outdoor? For outdoor, they use metal based. If you see a camera with screws, for sure that means that camera is having a metal. All right, so that's why you need external screws to fasten and hold it so it does not fall off by any chance or hurt someone. So metal based enclosure. Secondly, whenever you use metal or plastic outside in the sunlight, the plastic will start to fade. The color will start to fade because of UV. If you use metal, the reliability is much stronger. It will not fade. You might have seen certain old installation, the mount is different color, the camera has changed its color because of UV, right? Even your, let's say you dry your clothes outside, you dry it out in the sunlight. Let's say you put a dark blue color shirt outside, you forget to take it after 2 days, you will see it starts to fade, right? So that all happens because of UV effect. Then metal based also can withstand some kind of vandal resistance such as stones, wind. It can hold itself. It's like imagine driving a plastic car or a metal car, right? Of course, metal car, it's more heavy, can handle the wind. Next is stainless steel. Stainless steel is also a part of metal, but it's a different suit. It's like this. When when it's winter, you wear a different suit, right, to protect yourself. So for a camera, the housing is of a different construction, stainless steel, to protect from a certain environment, which can be corrosive environment. Let's say chemical factories, food factories, where water moisture is always present. The it can cause some corrosion. So, or beach areas. There are hotels with beachfront properties. You can use stainless steel. Now, question for you is, what if I don't have stainless steel? You can still use metal based, which is aluminum. You can use aluminum based. It will work, but it can fail soon. If stainless steel can withstand for 5, 7 years, maybe within 1 or 2 years or 3 years, you will start to see a standard uh, metal based cameras will start to corrode faster. Okay, so that's the difference. Both can work at first. Next is certified housing. Certified housing is a special type. In order to explain that, let me pull out the explosion proof camera. I will take our own example. Let's say Wisenet. Okay. Okay, so if you are okay, there is a question, can I use it in the barge? Anything to do with seawater, corrosion. You can use two things. When you have seawater and corrosion, there are two options. Either you can use stainless steel, or actually you can go back to plastic, which is weatherproof. Uh, that can also be used. Okay, weatherproof plastic, and then anything that can withstand corrosion, stainless steel. Next is certified housing. Certified housing are special housings used in mining industry, or explosion proof industry, or you can say petroleum industry. or petrol pumps or refine or fuel storage locations, because it could be for any reason. A small spark can cause an explosion. Let's say you go to the mining factory. In the air, there is a lot of combustible materials. It can be, just dust, mining dust, coal dust. If you go to a carpentry factory, there will be sawdust. If you go to petroleum, there will be gas. All these are ignitable, right? A small spark can cause an explosion. How do you know small spark? How do you switch on the gas? You put a small spark and then the your gas turns on. Same way, you can have an entire oil refinery come down, get burnt off because of a small spark, right? In order to protect that, you have to have special enclosure which does not um, which does not cause the spark. And even if there is a spark inside and there's an explosion, it will be contained within the camera. Let me explain this point. It's called intrinsically safe camera. There are two words, both of them mean the same thing: explosion proof. It does not mean I put a bomb, it will withstand the bomb. Uh, no, that's not the meaning. It means it's proof. If there is an explosion, maybe there is a small spark inside the camera, and maybe there is some gas which is somehow inside the camera. If there is a spark, if there is an explosion, it will not come outside. No single spark will be emitted outside the enclosure. It will be contained inside. Whatever explosion happens will happen inside the camera. Only that camera will fail, right? So that is what happens. Second thing, it itself will not cause spark. Okay, so it has been tested for that. Then this is called intrinsically safe or explosion proof camera. Certified housing. Why you need certified housing? If you are going to use, I mean, if by regulation in areas like oil and gas and mining, they call it zone 0, zone 1, zone 2, zone 3, and so on. Depending, zone 0 means the most as close as possible to the fuel itself, that area zone 0. Slightly away from the fuel tank, it's zone 1. All right, so there are different zones. Whatever be the case, all the zones you need explosion proof camera. Okay, then um, by regulation, you need explosion proof. Secondly, if something happens and you fail to comply to the regulation, you will not be able to get any insurance claim. Then, second thing, also, even during the project, its project timeline itself, you will not get a green signal to commission the project because one component is a vulnerability in that site, which can cause an explosion, cause lives, cause death, and so on. So this is what we are talking about camera body. Most of our projects will be plastic and metal. Bubble. Bubble is either stainless steel or, sorry, bubble is either glass or polycarbonate. It's also a form of plastic. Um, Standard glass means without vandal resistance. It's like the windshield of your car or the screen of your mobile phone. If the screen is cracked, if the screen is leaking, you cannot see what's happening on the phone. Same way, when you're driving, if the windshield is dirty, you cannot really see clearly. If it is raining without a wiper, you cannot drive properly. A camera is the lens is inside, the driver is inside, looking outside through the glass, through the bubble. We call this white, this down part. This is a bubble. This guy. You cannot see clearly. So a bubble should withstand certain things. One, if someone tries to damage the bubble, it has to withstand that impact. That's called impact resistance. All right. So the impact resistance, there is a standard called IK10. IK10 means a human being with a hammer tries to damage the bubble, it will withstand. Okay. In order to just say, understand in our layman word, a human being with a hammer, with as much of energy that he has, he tries to damage the bubble, it will still withstand. It can hold it. Okay. Now, Of course, there are, you can check online vandal resistant testing. They will show a hammer falling on the camera bubble and it still withstands without any cracks. Okay. All right. It's not only about the crack, it also about other things in the camera. I always take this example. Let's say if someone hits on your head with a hammer, maybe there is no bleeding, but inside your head there can be internal bleeding, right? Same thing with the camera. Just because the bubble can withstand does not mean the camera component should can move away, like the RAM or the motherboard or the lens. It should not get damaged also, right? The camera should work as if nothing happened. All right, that's why this testing has to be vetted by a third party, IK10 testing. You can find in for many cameras, you can find this IK10 testing. Okay, it's now become like a common standard. That's why today people don't try to steal the camera. They go and steal the NVR. If there is a robbery case, you will see um, they will go ahead and take the NVR because cameras have become more rugged now. They can handle a lot of impact. Okay, next is system on chip. System on chip. This is the main motherboard to the camera, or sorry, main processor of the camera. Just like your laptop, i7 processor, i5 processor, Celeron processor, i9 processor, Xeon processor. Whenever you decide for CPU, the first thing that you check is what is the processor speed. Based on that only your camera can perform, your laptop can perform, or how much it can perform. So a camera has many processes. It has to process image, it has to do a lot of image enhancement, image compression, it has to send the image, it has to do analytics. So a lot of work is required for the camera to do on the camera side. It is not doing on the back end, it's doing on the camera side. So when all this is being done, and just remember, camera cannot take 5 minutes to do one job. If the camera has to process the image, it has to do real time, right? When you see a scene, if a person is moving, immediately you should see the person is moving on your screen. That means it has to process the image. Doesn't matter whether it is bright, whether it is low light, it has to adapt IR and other things and analytics. Everything has to happen real time. So it has to work fast. So you need a good processor. The more the processor, the more features you can add in the future, more analytics you can do, better image processing you can do, and also better compression you can do. All right. So this is the brain of the camera or the heart of the camera where everything is linked. Now, all of this requires technology. All of this has their own technology, like camera body. You need a manufacturing plant to do camera body. You need a manufacturing plant to develop the lens. You need a manufacturing plant to do the system chip. So all of this requires R&D resource. Now you understand the impact of R&D. It's not just one guy doing one job. No, you need a electronics engineer, you need a hardware engineer, you need optical engineers, you need software engineers, you need many people to work on this, right? So an R&D team cannot be five people. It has to be quite sizable for any company. All right. Next, lens. We will see the lens part very soon in more detail, but right now, fixed lens, varifocal, and zoom lens. Fixed lens can be best explained. I will be now moving on with the fixed lens. Let's say, first let's understand about adjustable lens 192.168.160 and 601.42. Okay, adjustable lens. Adjustable lens is, let's say my camera now is looking at this meeting area. If I want to zoom in to a specific, let's say I don't want to look at the side area, I don't want to look at the right side, I can zoom in. This is called adjustable lens. Now my camera is mounted on the wall, but I'm sitting here and moving the lens, right? So this is adjustable lens or varifocal lens. All right. When you are not sure what lens is required for a camera, maybe you wanted to cover the door, maybe you wanted to cover the entire room, you are not sure. In that case, you need adjustable lens. And there is something called standard adjustable lens, called standard varifocal lens. It covers generally most of your zoom or most of your requirements. We will see that also. We will see that more in the coming slides. So this is adjustable lens, and then I have a fixed lens here. This one I cannot adjust. It is already fixed. If I want to move it forward, I have to move the camera. I have to move the camera to another location. The lens cannot be adjusted. So that is called fixed lens. Okay. Then comes zoom lens. Zoom lens is typically used for larger coverage. Let's say this particular camera, when I zoom in, there is only a certain distance up to how much I can zoom. Maybe 10 meters, 15 meters I can zoom. There are some cameras which you can zoom slightly, maybe 20 meters, 25 meters, but that's about it. A zoom lens is a different, you can say it's a different architecture in the lens structure used for very long distance. Now let me take one in camera and explain. Here we go. So I'm going to zoom out. It looks at roughly close to 5 kilometers, 10 kilometers. It looks at very far distance. So this is the idea behind zoom lens. So let's say I want to look at the car there. I can draw a square and it goes all the way and starts to zoom in and try to pick out the details about that subject. Okay, what is the idea behind this lens? If you want to do um, large distance monitoring, let's say maybe some accident happened and you want to just go ahead and look at it, you can just zoom in and check, okay, what happened, who caused the accident. Sitting at my office, I can have a look, right? I can look at all 360-degree. By the way, I can move this camera. I can move 360-degree. Okay, so it's a zoom lens, but it's also a rotate. I mean, we call it pan, tilt, zoom. I can pan. Pan means rotate, left, right, rotation. Then tilt. Tilt means it can go up. Already it's up. Then let's go down. It can also look down. Got it? So pan tilt means tilt up and down. All this can be done remotely. So this is a 55x zoom. 55 times it can zoom from its original location. So this is called a zoom lens. This is how it is specified. 30x zoom, 50x zoom. From the current location, which is right here, I can zoom 55 times, 30 times, 40 times. So that's a zoom lens. All right, zoom lens. Expensive. The first two, most affordable is fixed lens, but there is a lot of catch. Fixed lens, you cannot adjust. If you cannot, if um, let's say this is the challenge generally. Let's say, let's say you want to look at the door and the camera is looking at certain view. If it is a fixed lens, you cannot make any change. You have to leave it, or you have to remove the camera, move it near the door, right? So re-pull the cable and so on. However, if you have adjustable lens, you have some flexibility. You can move the lens, zoom in, zoom out, adjust a little bit. Okay, and when you are looking for operational requirement, PTZ, these are PTZ cameras, incident monitoring, uh, general movement monitoring, your VIP patrol, you want to follow certain VIPs, exhibition halls, you want to look at generally what's going on. These areas you can use PTZ cameras or, panel zoom, and you can look 360, right? So you can use one camera for every 100, sorry, every 500 meters, every 1 kilometer, you can use one camera. Okay. But just remember, when my camera is looking at this location at the door, it cannot look behind. Or maybe someone zoomed in towards a wall. That means right now it's only recording this wall. So the PTZ camera, there is a risk if um, if some particular operator uh, they want to misuse, they want to move the camera to a certain location and away from the door, they can do it. Of course, you can lock. We have user controls, you have authority to block all that. You also have settings where the camera will come back to its original position after some time. All that is there, but a PTZ cameras or a zoom lens camera, it allows the operator to move away from the original intent of look monitoring, right? So you have to use it with caution. That's why many regulations do not allow PTZ camera, like CIRA regulation or MCC. I'm not 100% sure, but they don't allow for a critical monitoring. They don't allow PTZ. You can use it as per your operational requirement, but it does not meet the minimum criteria, monitoring entrances and so on. Okay, back to the bubble. Bubble, there are different grades. Uh, Scratch resistant bubble, water resistant bubble, water drops will not stay. So there are different grades of bubbles. Those are all like, it's like leather seats, like extra features. You have a seat, but if you want leather seats and all that, it's like that. You want special grading on the bubble that has to be requested separately. Okay. Discoloration can happen again for after prolonged use, or if someone is using chemical to wipe the glass. It's not supposed to be used because maybe they have a coating. If you use some chemical, it can cause discoloration. So in that case, you can replace only the bubble. That can be done. All right. Next is the software. The camera, in order to operate the camera, right now, I am working on the camera, right? My camera is a lens, camera, so many settings. How am I working on the camera? I am going to the live view, I'm going to the settings. That means there is a software running in the camera, user interface for me to communicate with the camera, right? So there is a software running to make changes, to do some settings and so on. That's the software. There is also one more software called OnWiF, which we will see in the coming slide. What is the OnWiF all about? Then in addition to all this, everything else can be optional accessory. You need microphone in the camera so you can record audio. You need additional alarm inputs in the camera. You can connect a door contact. If someone opens the door, it will camera will pop up. Or you need additional IR. The camera can see in nighttime. It's like camera having a torchlight. So these are all SD card additional features. Now all these additional features today are like standard. Many brands are just giving as a default. feature with IR, with microphone, input, output, and so on. But back then it was like a optional accessory. Today also IR is optional. Some cameras don't have IR. We will see about IR after our first break. So let's take a break for 10 minutes and then we will catch up. All right, let's resume. Okay. So, before we understand how the image is enhanced, how the image is accurately captured by a CCTV camera, first we need to understand who's responsible or which component in the camera is responsible for making sure image quality is good. The first component is the lens. The lens is the one which receives the light. It receives and focuses the light, just like your human eye. Camera is like a copy of a human eye. You light falls on the eye and it falls on the, believe, retina, where the rods and cones are there, and then it changes to say color and other things, right? Same way, for a camera, the light falls on the lens. The lens will uh, focus or ensure that whatever light is received falls on the sensor. Oops, this guy, second one, sensor. Okay, light is received by lens. Second, light falls on the sensor. What's the job of sensor? Is to convert the light into electrical signal, right? It's an electronic component, has to convert to electrical signal. After that, it can do all the processing and everything. Okay, so the first two components can be adjusted. I mean, how much of light is received is decided by the lens. How much of light is not received also decided by the lens. If your lens can do a good job, like the uh, bigger lens or can narrow lens, different specification. How much of light falls on it is will directly equate to how much of image clarity you get. Second is image sensor. Image sensor also there are two types, CMOS and CCD. Again, we will see that in the coming slide. And image sensor, even bigger image sensor gives you better image quality. Why is the DSLR cameras having better image quality? They have bigger sensor. One of the main reasons, right? And then of course the software processing also contributes to the image quality. It's like this, a drawing board. Image sensor is like a drawing board. You have to draw the picture on a small drawing board. I mean, you can draw the same picture on a very big drawing board. So bigger drawing board, more clarity, more details. Smaller the drawing board, everything is cramped, right? So image sensor is where it's like a drawing board. If it is 2 megapixel, this sensor will have around 2 million pixels. If it is 5 megapixel, it will have 5 million pixels. All right. And if the sensor size is the same for 2 million and 5 megapixel, 5 million pixel, that means 5 mega will be more cramped, right? It's like they will overlap. They will sit on top of each other. The image quality will be slightly blurry, not clear in critical lighting condition. So image sensor also is dependent. Okay. Now, just because image sensor, I need bigger one, you cannot say I need a very big sensor. There are certain, best practices which we will see. This is one of the key points of today is just because I need a lens does not mean I will buy the biggest lens. Then you have to buy a bigger camera. Then you cannot put it on the ceiling. You have to buy a special mount and mount the camera. So you cannot always go to the extreme side. You have to find the balance when it comes to CCTV. What is suitable and majority of the work, it's not your job. The vendor has already done that. He has already done and he will specify on the datasheet and say this camera can handle so and so lens, can handle so and so resolution, and can handle so and so lighting, how low it can handle, how high it can handle. All that will be mentioned on the datasheet. Okay, so we follow certain you can say 80-20 rule. 80% of the camera will have the same lens combination, will have the same sensor combination. Okay, done. Now next is CCD and CMOS. The reason for covering that, actually it's not important to cover in today's market, in today's time, but I have seen certain specifications or certain documents still mentioning CCD. CCD is the image sensor, that's okay, but it was used during the analog time, analog camera, the older camera, when cameras were first, um, 10 years back, you would see CCD prevalent in the market. Okay, then came CMOS. CMOS was cost effective, but they had some CMOS was not very great when it comes to low lighting. However, today the amount of investment and R&D done on CMOS has made CMOS the sensor of choice even compared to CCD. Okay, today if I give you 1 hour, you will still not be able to find one camera with a CCD in 5 megapixel or 2 megapixel, right? Because it's become so rare that in the IP camera industry, in megapixel also in megapixel industry, you will find CMOS taking the lead, and majority of the vendors have opted to go with CMOS because it has other benefits. Of course, CCD was the first sensor type that was introduced in the CCTV. CMOS was much more advanced when it comes to the amount of R&D that was done. It has lower power consumption, which is very important for IP cameras because they are, you cannot. It has IP camera take power from the switch, network switch, right? You cannot take a lot of power. Then um, there are other things such as converting analog to digital. It is done on the, I mean, it is not compiled and done, it is done on the pixel side itself. More circuitry is there, but however, generally speaking, CMOS is your sensor of choice today in almost every CCTV camera, which is megapixel, you will find CMOS. Okay, and you don't have to hesitate because even your mobile phones, you see the iPhone and Samsung phones, the image quality is very good, no doubt, right? And they still use CMOS. So it has advanced to a stage where you cannot question that anymore. CMOS is fine. Um, both of them do the same job, convert light to signals. Okay, it's no longer a difference. Okay, next is WDR. Okay, so one of you asked a question, what is a WDR? What is CMOS? CMOS is not operating system. It is the sensor of the. It's a hardware. It's a sensor of the camera where the light is converts light which is captured by the lens into electrical signals. Okay, that's the second section. It receives the light and converts it into digital signals. Okay, okay. You, one thing about CMOS and CCD is the reason for covering that is if someone tells you CCD is better than CMOS, you should go to CCD. Or if someone tells you, you just have to have a neutral opinion on this. You should not be biased. You should not take one over the other uh, because it can be used to make, I mean, to lead you in the wrong direction if you don't have the knowledge. So that is the idea for today. The idea for today is not to tell you use this only, don't use other brand. It's not like that. It's to give you that knowledge so you can make the right choice. Both of them are doing the same job. Okay, if someone says CMOS is bad, no, it's not bad. It is good, even if all the megapixel cameras are using. If someone is still using CCD with providing megapixel, okay, no issue. They were always good, and maybe if they have a newer sensor and doing same job, no issue. So you should not be biased towards one. That's the whole idea. All right. Okay. WDR. WDR is okay. We will be talking about two, one, two, three, four lighting concepts. How camera works. Okay. Uh, Camera has to provide a usable scene. On the left side, I cannot see the scene properly. Behind, it's too whitewashed because there is too much of light. The camera is confused. It's just like us, human being. If you look at the sunlight, the amount of light coming from the sun is too much that you automatically close your eyes because there is too much of light. Okay. Then, when the light is very less, for example, when you go home, when you switch off the lights at night time, suddenly everything is dark. You cannot see anything. Then slowly, you are able to see some objects. So what happens is your brain is telling your eye to open the iris to allow more light to come inside. Okay, it's the opposite. When you look at the sun, your brain is telling close your eyes because you're hurting yourself, right? But when there is no light at night time, when you switch off the lights, suddenly everything is dark. Then slowly you get to see the object clearly. That means your brain is telling, or or basically your nervous system is telling you that to open the eyes more wide so you can get whatever light is available and you can see something clearly, right? Basically, your eye is dependent on light. Same thing. Camera also is dependent on light. Just like when a camera is looking at a very bright sunlight, it will also close its eyes. So, or it can be overexposed. So, first picture, it is overexposed because it opened its eye, it is blinded by the sunlight. Sometimes when you look at the projector lighting and when you look at the projector lighting for a few seconds and then you look somewhere else, you can see white spots, that blinding effect. Same way, when the camera is looking at a very bright light, it is blinded. It's called overexposure. It's overexcited. The pixels are overexcited. Pixels have a value. It just goes all the way to the maximum. It's like full volume, right? So it is just whitewashed. Okay. However, if you tell the camera, you can just like your human eye, your nervous system is telling you to close your exposure so you can see at night time. You can do that to the camera. You can say, okay, stop opening your eye too much, close it a bit. But if you do that, your your camera becomes darker. You see the image? Because it's now closing its eye, the inside area is darker. This is the issue with the camera, which does not have WDR. It can either do the first one or it can do the second one. It cannot do what you see on the right side. You cannot see both inside and outside at the same time with a very clear picture. All right. Either you can do long exposure or you can do short exposure. Long exposure means you keep the eye open, it just get overexposed, it become blind on this area, but you can see inside. Short exposure means you're closing your eyes, you're allowing less light to come inside, but the benefit is now I can see outside area very clearly. I can see the clouds and everything, but inside I cannot see. Okay. Now, uh, this is a I have here, I believe. Backlight. I'm going to switch off WDR for this camera. Okay, so when I switch off the WDR, you can see the room is a bit dark and the window, I cannot see anything, overexposed. Now, when I activate WDR and I can say, okay, by the way, the moment I activated WDR, now you can see outside. You can see if someone is standing behind the window also, you can see there is a person standing. Right? So the camera can now handle two types of lighting. This is the job of WDR. A WDR camera has to handle two different lighting condition. Lighting condition 1, lighting condition 2. All right. A camera is an electronic equipment. All right. Just think of it this way. Whenever a camera is positioned, let's say, let's say I switch off the WDR. Whenever the camera is positioned here, the camera will look at the scene. It will see the bright sunlight. It will close its eye automatically, just like us. It closes its eye and make sure in the majority of the area it can see something. Okay. And this is a non-WDR. It can handle only one exposure. Okay. Let's write down some note. A WDR, okay, a non-WDR means single exposure camera. It can handle only one exposure. It can see either inside or outside. Cannot do both. Okay. Now the same camera, let's say, um, let me try something. Okay. Now what I did, I reduced the exposure. When I reduce the exposure, I can see outside, but inside is so dark. Okay. This is exposure number two. A camera can do either see everything on the inside, or now it can see very clearly on the, I mean, see everything on the inside, or it can see outside. Okay. What is the light level, or light is measured in lux? You can say lux level of sunlight. Around 100,000 lux. It can go up to 100,000 lux, let's say afternoon time, direct sunlight. So here, outside sunlight, let me reset. Okay, backlight, WDR switched off. Okay, now this area is 100,000 lux. 100,000 or 100K, 100,000 lux. Okay. What about lux level of typical office? Usually in the office, we are providing fluorescent lights. You can say man-made light, right? We can never provide as much as God provides, like pure sunlight. We can only give around 500 lux, lux level of, even if you take stadium, there is a standard, let's say, if it comes, um, 700 lux. You can go 1000, 2000 lux. Some football stadiums they go up to 2000 lux, but you can never reach 30,000 and 100,000 lux. That is not possible. So as long as okay, um, so here in the scene, lux level outside is too much. Inside office around 300 to 500 lux. So you see the difference in the lux level outside 100,000, inside office. This is sun. Let's take example 100 lux. So what is the ratio? 100,000 divided by 100 is 1000 is to 1. So if inside is 1 lux, outside is 1000 times more. So if you see the ratio is very high, the difference in the lighting condition in the same scene, according to the camera, it's the same area. It is looking outside as well as inside. So in the same scene, if there are two different lighting conditions of very wide difference, very big contrast, very big contrast, that means it's a wide dynamic range area. Wide because outside lux is too much, inside is also very big difference. Dynamic range, I will explain why. Sunlight keeps on changing, it is not fixed. Afternoon lux level is different, morning time lux level is, so it keeps on changing. It's a wide, big difference, and it's dynamic, it keeps on changing. So you need a camera which can handle this dynamic change in lighting in the scene. All right, so that's why you need a WDR camera. Okay, in order how does WDR camera work? A WDR camera is it works twice, or it uses the processor more than, I mean, twice as a normal non-WDR camera. It takes two pictures at the same time. You won't realize it because it's all done in the camera side. The moment I activate, turn on WDR, it will take two pictures. It will open the eye, take one, close the eye, take one, and stitch them together as one single picture. Okay, why does it do this? When it takes the first picture, it will remove all this area. It will just reject all this area. When it takes the low exposure picture, it will reject this area. Then it will stitch this here, and it will stitch this part here as one single picture. You won't realize, and because it's giving you one combined picture. Okay, so it works twice as fast, but it gives you one combined picture. Let's use your WDR. This is how WDR works. You can go to any brand, any vendor. You can check in even in their data sheet. You will find they combine. It's called multi-exposure camera. They combine two frames to give one single frame. Okay. Due to time, I will not be comparing other vendors from their data sheet, but you can check. There are different levels, ratings for WDR: 120 dB, 150 dB. So one of our cameras, they use four frames. Instead of two, we take four different picture, we combine them to give one single picture. How do you combine? If you have to give 30 frames, 30 picture per second, we take 120 pictures. Let me make this clear. So we take 120 pictures, we combine every four picture and give you a single picture. Okay. Higher the WDR. What is this higher range? Higher range means higher contrast it can handle. Difference that 1000 is to 1, it can be 10,000 is to 1, it can be so and so. The higher the contrast, higher the WDR. For example, you go back to the Excel sheet. If the ratio is 1000 is to 1, you take a log of 1000 to the base 20, that is 60 dB. So we don't specify 1000, 10,000. We just mention the ratio difference, 60 dB. If this is 10 lux, very low light, and the outside is very high, like hotel entrances, maybe they have very low lighting, or shadows, they have low lighting, you will require higher WDR. Higher the difference, higher the WDR. Okay. Now, question for you. Which areas require WDR in this picture? I have explained this to some of you, I have attended other trainings. When there are two lighting, outside sunlight, indoor decorative ambient lighting is very less, two different lighting and very wide difference, you need WDR. Second one, here also you need a WDR. Why? Because there is darkness, shadow, and the car camera is inside looking at the car coming, right? So car is coming from the sunlight, but suddenly it goes inside, there's a shadow, and it has to manage two lighting, cameras looking outside as well as inside. You need a WDR. Staircase, if there is no window, then you don't need a WDR. Lift lobby, lighting is uniform. There is no change in lighting. It's fixed lighting. You don't need a WDR. Hotel compound, if the shadow can occur here, sometimes if the sun is here and then there can be shadow, that means there are two different lighting for the camera. There is sunlight here and there is shadow. That means it has to have a WDR. Same way, border security, of course, critical locations, you must ensure all possible conditions are covered. Okay, so that is WDR. The next is opposite of WDR. As long as there is sunlight, you need WDR, period. Next, highlight compensation, HLC. It's the opposite of WDR. There is no sunlight, no sunlight at all, but suddenly there is a car coming with a headlight. Headlight is what? Strong lighting, right? Because of the strong lighting, there is a chance that nearby pixels get overexposed. This is called as a blooming effect. Let me open another slide just to explain. Okay, no issue. So this is called as blooming effect, where the um, when the okay, it's like this. The camera is not expecting a sudden light which looks like this because the almost rest of the image is dark. So camera is like keeping its eye wide open, looking for light. Suddenly there is a car headlight, too much of light. The camera will be like, what? And because of that, there is a effect called blooming. So there is a feature in the camera called highlight compensation. It will mask that light. It will just mask it. Okay, the same camera here, I can I have a feature called HLC. I can also mask I can mask this area, so it will stop affecting the nearby pixels. Okay, so that is called highlight compensation. It's the opposite of WDR. When the camera is looking at a very dark scene and there is a street light or there is a signboard and that is affecting a person standing near, you cannot understand his maybe there's a car, you cannot see the number plate properly, or there's a person, you cannot see his face properly, then you will need a HLC camera. Okay, and let me just see, pull out one video to make it more understandable. Just a second. Okay, so while it loads, next is low light. A camera requires light to see. Okay, let's just a second. Okay, so there is one video here, highlight component. It's a very old video, just to explain to you how this works. The guy is coming with his torchlight. The camera is blinded. On the right side, although there is a torchlight, you can see his face. You know who's the person. At least you can recognize, okay, this person, I know who is he, right? So this is the effect of HLC. It will stop from nearby pixels getting overexposed. Okay. Next is uh, Next is a WDR. If you see in data sheets, you will find 50 frames per second. But when you activate WDR, it becomes half, 25 frames per second, because you have to combine two frames to become half. This is only for people who have that, because these are third-party data sheets. I don't want to open them here, but just to give you an idea, WDR is mixture of two frames to give a single frame. So this is how other vendors or do it. If someone has a different method, just explore the option, because there are different artificial methods of doing WDR called digital WDR, electronic WDR. What they do is they only increase the brightness or reduce the brightness in that dark area. That's it. But when you increase the brightness, let's say 60%, you're increasing. Then after some time, the sunlight will change. Again, you have to go manually and adjust it. So you have to keep doing this manually. Every time the sunlight keeps changing direction, you have to do it manually. So this artificial method of WDR, electronic WDR, first they are software based, they are not hardware based. They do not take two pictures. They only take the same picture and do some adjustment. And it requires constant calibration every time the sunlight keeps changing direction or intensity. So that's not a real WDR. Okay, so that is the electronic, or you can just say a fake WDR. Okay, they can be still 120 dB, but it's not multi-exposure WDR. Excuse me. All right. Next is IR illuminator. This is not our picture, but I just want to give you an example. A camera which does not have light, it will look dark. Image will look dark because every camera requires light. If you see that the first component in the camera is to gather the light. If there is no light, it cannot produce an image. So just like a human eye, if you switch off the lights at night, you cannot see anything, right? You cannot see, no matter what you do, you cannot see anything if there is no light, right? So what you do, you carry a torchlight to see. Same way, on the camera, you can insert IR LED. Let me, hmm. On the camera, you can have IR LEDs. So let's say 6080R. Okay, do you see these small LEDs in front? These are IR LEDs. When the camera identifies that the scene is dark, automatically it switch on the LED. But the benefit is, human being, we cannot see IR light. Cameras can see IR light. Um, this is the light spectrum. Okay, visible light. You know the Vibjor in the school we learnt when white light passes through a prism, it gives you 7 colors like the rainbow colors, right? We can only see visible light. Human being, we can see visible light 300 to 750 nanometer. Then there are other rays, infrared rays, IR beam, UV rays, X rays, gamma rays, and other things. Camera can also see IR. They are sensitive to even look at IR rays. That's why we cannot see when IR LED is on, but the cameras can pick it up. Okay, so what happens when you turn on the IR at night time? Suddenly the camera is able to see the same image more clearly. Okay, so this image now looks like this. Again, this is taken from Google just to give you an idea. This is not our camera. I'm not sure which camera, but just to give you an idea that at night time you can now see black and white. So on the left side is like a black and white image. You can see the picture clearly. Now you have a torchlight, you can see. Okay, what is the benefit? The benefit is you don't have to turn on the lights. You don't have to pay for electricity to turn on the lights. You don't have to unnecessarily waste resources just because camera wants to see. The camera itself will give its necessary light through the LED, and it will consume very little power, and it can see on monitor at night time also. Got it? So that is a benefit of cameras with LED. Any outdoor cameras, it is must or mandatory or good recommended to have IR LED because you cannot control what lighting is there outside, right? Um, but uh, but if the cameras have, of course, IR LED, they can turn it on by itself and start monitoring. Okay. Now then comes low light. Okay, there is something about IR LED. IR spectrum does not have visible light, does not have color. Only the visible spectrum has these colors, beautiful colors. IR light is only shades of black and white, just gray. Okay, let me just show the snapshot once again. It just shades of black and white. It's just grayish image, right? Monochrome. You cannot see color. But today, in current scenario, today's world, black and white is not really accepted in many projects. Many projects they want to see color image. They want to identify what is the color of the car. Is it white color? Is it gray color? Is it blue color? If it is just shades of black and white, you will see all the guy looks the same. all of them wearing a suit. You cannot really make out the difference, right? So going forward, for more efficient monitoring, they want to see color image. Okay, there can be a situation in the night time, this particular area, there are no street lights or there is only one street light, and the camera, of course, cannot give color image with one street light, not enough light available. That time it will change to black and white. So what do you do in this scenario? When you still need color image, that's why you have technology called a low light. Low light. You still need some light. It's not like zero. You need some light, but the camera is very sensitive to that low light. How is it sensitive? If you remember the camera component, what are the two things that is responsible for getting the capturing the light? First one, lens. If you can manage to provide a lens which can open very wide, that is one. Second, if you receive a lot of light, you also need a bigger sensor. More light, more sensor. Okay, so this is what uh, we are going to see. Okay, any lens in the world, even your mobile phone, if you go to GSM Arena and go open the datasheet of your camera, or sorry, a datasheet of your mobile phone, you will see next to the lens, it will be mentioned f-stop. Okay, you take any datasheet of any lens, it will be mentioned f-stop. F-stop is the capability of the lens of how much of light it can gather, it can take. Okay. Higher the number, smaller the opening for the light. It's like your iris, right? You open and close your eyes, same like that. Higher the opening, higher the number, smaller the opening. Lower the number, bigger the opening for the light. So, whenever there is a low light situation, any lens which has a very good lower number of f-stop, it's good because they can give you more bright picture at low light. You know, you can take as an exercise. You can take any of your favorite camera, open the datasheet and check. It will have an f-stop mention. The most common number is 1.4, slightly better 1.2. But above this, you will you will not find many cameras in the market. 1.2, 1.4. You take any commercial camera, you will not find DSLR lens. Um, Almost rare to find below 1.4. It's like the common lens production. So there are few vendors. One of them is our brand, Hanwa. We have our own optical engineering. So we developed our own lens to make it slightly, you can say, open the lens even more wider to gather more lighting, to get more light. Okay. Then also the sensor, image sensor, also we have made it bigger. What is the typical size of image sensor? 1 by 3 inch or 1 by 2.8 inch. These are the typical image sensor size. What is 1 by 3 inch? Uh, okay, here we go. Just a second. Okay, so um, okay, so behind this lens, at the back side where the light is falling, this is the image sensor. It's square, right? 1 inch, 1 by 3 inch. 1 by 3 inch means smaller. Um, okay, this is a very good picture. You can see if you remove the lens, you can see the sensor, image sensor inside. So smaller the sensor, 1 by 4 inch is smaller. If you can see, smaller area, bigger area. 1 by 3, 1 by 2.8, these are the standard. 1 by 4 will have is small actually, it will have poor quality. 1 by 2 will have very good quality of image at low light. Okay, so having said that, there are two factors we improved. One was the image, the lens f-stop. Second was the image sensor. You can take many low light cameras. This is where they will attack to make sure to give a good low light image. On the left side is a camera without low light. On the right side is a camera with low light. Same scene, same location, but the right side camera can give you color picture because it is a low light camera. Whatever lighting is available, it will take. You see the lights are still on, right? So whatever is available, it will still pick it up and give you a color picture. That's the job of a low light camera. They are slightly expensive because you're using a premium sensor, you're using a premium lens, something which is not standard, okay, slightly above the standard requirement. All right, what is the benefit of low light? You don't have to increase the street lighting to get color camera. It's more expensive. You don't have to invest in more lighting to get a color image. You can just buy one camera to monitor that entire scene with a low light. It will give you much better cost saving compared to you investing in more lighting. Okay, let me just look if there are any questions. Can you share this so far? Okay, yeah. All right. And the next point, the PowerPoint, I can email it to you as well. Today I'll be emailing it to you. No worries. Next is IR illuminator. We saw about IR illuminator. They are LEDs on the camera to make sure they can see at absolute darkness. Okay, it's like complete switch off of lights. The camera will automatically sense there is no light, just like a human brain. It's pitch black, then it will turn on the LED and start monitoring. Okay, then the IR LED, there is a range of how much the LED can reach. That is different from camera to camera. Some camera 70-meter IR, some camera 50-meter IR, some camera 30-meter IR, some of them 20-meter. Now 20-meter itself is good because your corridors are usually 15 meters, 20 meters. Okay, good enough. Your parking lot may be 20-meter, good enough. But it's okay to have 30-meter. Some area you might require 50 also. So if you look at the lens, first one, it has a lens of 5 to 60 mm. That means it's an adjustable lens. It's not fixed lens. You can adjust as you like. You can zoom in, zoom out as you like. We will see more about it, but it's an adjustable lens, mm. So because you are seeing as much as 60 mm very far, you have also IR range, which can reach much more up to 70 meter. The second camera has 4.1 to 16.4. This guy also goes 70 meter. Okay. Then the second one, third one, 2.8 to 12. This is your standard lens. We will see why it is called standard. This one up to 50 meter. Okay. You will see f1.4, f.94, f1.6, 1.6, all this specified. Okay. 30 meter. Fine. Then this is a fixed lens, 2.4 fixed. You cannot adjust. And 2.4 is supposed to be like a short distance camera. That's why 20 meter. 4 mm is slightly long distance camera, 30 meter. The second one is 30 meter. So depending on how much the camera itself can see, based on that, the vendor will have the IR range accordingly, right? It's not like the camera can see 50 meter, but the IR is 20 meter. Okay. But again, uh, this these kind of things on reputed vendors will take all this into consideration. So you have to also, I cannot give a general statement that every vendor will do the same. Then what about 70 meter? That is fine. But if you just recollect a few before the break, we saw PTZ camera. We saw this guy. Let's say, okay, we have to turn on WDO. But anyway, now it changed to the outside view. It's now 6 kilometers. If you can take Google Map from our office to the port area is around 6 kilometers. Now, um, if I have to see this at night time, if there are lights, okay, it will see. But if there are no lights, how will the camera see at a very long distance. All right. So in order to see very far with a PTZ level camera, you need a IR beam which can move with the lens. So this is a, you can see this image. There are two LEDs on top of the camera, and there is a lens. When you zoom in, the IR beam also zooms in. When you zoom out, the IR beam also zooms out. So this is how you achieve variable zoom IR. Okay. So depending on how much you zoom in, the IR beam zooms. Depending on how much you zoom out, the IR beam also zooms out. You got it? So this is how you reach longer distance with IR. So you don't need too many IR LED, right? You just need two LEDs, and with the lens, you can achieve greater distance. Okay. What about the other cameras? Even in these cameras, each LED will have slightly different spec. When you zoom in, automatically a different LED will kick in, and it will be responsible for long distance. That's why there is more than one LED for short distance as well as long distance, and to make sure it covers the entire image, called uniform coverage. So it's called uniform coverage. More LEDs to make sure it covers the full scene, right? So these are small factors that improve the image quality. Next is we talked about WDR, too much light from the sun, camera should still see. Then we talked about IR light, no light, camera has to still see IR LED. Then low light, there is some amount of lighting, and you need color picture because IR will give black and white. As you can see here, again, IR gives you black and white, but you need color picture. In that case, you need a low light camera. Okay, done. Then last one is thermal camera. A thermal camera, what if, let's say, border security? Who's going to give light for the entire border? Let's say you're monitoring a seashore. Who's going to provide light across the entire sea? Not possible, right? We are not going to light up the entire sea just because I want to monitor. You cannot put lights over the entire desert because you want to monitor. So you need a camera which does not depend on light. That's called, then what else should it depend on? Heat. There is a camera called thermal camera which depends on heat, not light, and it can pick up heat radiations emitted by the body. So my colleague is sitting here. There is a heat emitted. You can see heat emitted. So the camera is sensitive towards heat, and it will draw colors. Red is hot, minimum is blue. So you can monitor distances of 5 kilometers, 10 kilometers where you cannot afford to put even IR LEDs. Those kind of monitoring, you start depending on thermal cameras. So thermal cameras can see up to 3 kilometers, some can go 5, some can go 10 kilometers, depending on the lens, right? They look almost the same size, but they depend on heat. Because they depend on heat, they can go at a very far distance. Also, there are some calculations why it can go very far, but we don't have to cover that today. But generally speaking, thermal cameras are quite capable of covering large distances. And it's shades of black or shades of rainbow color. So you have to complement a thermal camera with a PTZ. So when the intruder is coming nearby, you can zoom in and see who's the person. Until then, the thermal camera will do the job with above the range of a normal visible camera. Okay, thermal camera, they have now new features such as spot temperature monitoring, actual temperature monitoring. So you know whether it's a human being or whether it's a car, depending on the temperature range it monitors. Or if you're monitoring factories, you can see if something is going to explode or something going to fail, the temperature increases. So it can be used for other operational purposes also. Anyhow, thermal camera depends on temperature. All right. And we are coming to a close for the first day. And tomorrow we will be covering about lens. And in the next few minutes, let's close the f-stop because we already covered f-stop. And I can give you an example here. F-stop is the lens. F1.4 means more opening. F20, F30, they are smaller opening. Okay, so here, let's, so what I'm trying to show, I think it's loading. I'm trying to show is the f-stop. Maybe I can show it live. I'll take maybe this camera. All right, so let's understand how f-stop works. Iris, opening and closing of the eye of the camera, it is done automatically by a motor called DC motor. If the light is too less, automatically it will open. If the light is too much, automatically it will close. That is called iris or DC iris. There is a motor to the camera which will automatically open and close. Okay, DC iris. Now I make it manual. I am going to control the opening manually. Now, if I increase f-stop, boom, images dark. You see the image struggling, it's dark. Okay, it is trying to do something with shutter and all that. Uh, just make it difficult for the camera. So when I increase f-stop, image is dark. Now watch this. When I increase the f-stop or reduce the f-stop, boom, it can now see. So it's a difference between night and day. Now I am not going to do this manually. I will tell the camera, do it yourself. It's called auto iris. If I switch off the lights, automatically it will open. It will reduce the f-stop. If I switch on the light, automatically it will choose somewhere in 1.8, 1.10, sorry, F2, 2.0, whatever it requires, it will choose to make sure it gets a good image. There are other things, shutter, which we will see in the next class, but you got the idea. Opening and closing of the iris is done by a motor called DC motor, called DC. There is also stepper motor. Okay, it's called P iris. Let's just have a look at this. Okay, DC motor. The steps are very different, as in either here or here, right? It's like a big step. Stepper motor is very fine-tuned. Maybe you need 1 point f1.23 like that, very small steps. So there are two types of motor which controls the iris opening and closing. One of them is DC iris, the other one is P iris. P iris uses stepper motor. Both are good. 95% of the cameras are DC iris. Nobody has an issue, but P iris has slight benefit. Okay, in this video, we intentionally made DC iris look slightly bad, but it's not actually like that. Just to give you an example. Okay, so in a DC iris, there is a chance that the camera will focus on the person nearby, and behind it can be slightly blurred. With the P iris, the camera will find a very fine spot to make sure entire image is in focus, even backside or the front side. So you can see the difference. Most of you did not really see the difference, but actually, even in DCRs, you can almost reach this level. So it will find slightly a more different focus point because of the stepper motor, fine steps to give a finer picture. Very, very minute differences in real time. It's not a deal breaker generally. Okay, so we have our many series are all PRS based. Some of them are DCRS based. So you can use any one. All right. As long as you have DCRS or automatic RS, it's good because you don't want to manually change. Okay, so that's something that you have to just keep a note of. Most of the cameras are DCRS. All right. So that brings us to the end of today's class. You can expect an email from me. I have one question. I will answer that question. You can expect an email from me for the PowerPoint and a quiz link. Okay, every day there will be a quiz. You have to attempt the quiz um, just to check your whether you have attended the class, you have listened to the class, and every day we will just monitor the quiz. And once you have attended the quiz, that's it. Just keep forget about it. Attend the next day, and after the 4 day, we will check your attendance and we will check the quiz, and then we will issue a certification. Now, this is how the certificate looks like with your name, company name, course name. If you are a Bixi engineer, you have a Bixi certificate, you can get 7 credits, CEC credits. So we have the approval from the Bixi for this course for 7 CAC credits. Till end of next year, you can use this to renew your Bixi certificate. Okay, so that is the summary of this certification process. There is a quiz and attendance. Both are mandatory for the certification. All right. And let's just go back to the questions. So there is a question, what if the varifocal lens is not motorized? How do you adjust? If your varifocal lens is not motorized, you have to manually go and zoom the camera. Physically, you have to rotate the lens. Then you can zoom in, zoom out. There is a button on the camera called zoom in, zoom out. You have to manually rotate. You know, it's like your DSLR camera lens. So this lens, how do you zoom in? You rotate manually, right? Same way in the camera also you can rotate, zoom in, zoom out. Only thing you have to do it manually. There is no digital button. It can be done. It is still a varifocal lens, non-motorized. You do it manually. Okay, will the low light camera still have IR? Yeah, IR will still be there in a low light camera because that camera is designed for those kind of application. In worst case, it will switch on the IR and go to IR LED mode. Okay, so regarding the zoom ratio, we will be looking at it tomorrow. Vineet Kumar, your question, we will answer it tomorrow. The optical zoom ratio, because it will be covered in the next class. The course has been recorded, and the recording also will be shared with you for your references. All right, thank you so much, and feel free to be in touch if you have any further questions. The course recording, um, it will be sent via WebEx, so you have to view through WebEx only. So we will send you that recording. Okay. All right. If there are any further questions, I'm online. Meanwhile, the session is completed and you can disconnect anytime.